Hi guys! Today we are going to continue from what we left off yesterday. We will have to review some special triangles from geometry because we are going to use those two triangles. So there are three special angles and we're going to talk about sine, cosine today, and then tangent will be later. Alright, so you probably have heard of something called SOHCAHTOA, right? SOHCAHTOA. It means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's very important that you know where opposite is hypotenuse and adjacent is. So let me draw just a random triangle. And it's a right triangle because of this symbol. So let's say that this is my angle. Often we write angle as a theta. So this is a theta. It often indicates unknown angle. So opposite is the opposite of this angle. So this would be the opposite side. Hypotenuse is always the opposite of a right triangle. So it's the longest side in the right triangle. And that whatever is left, the next to the angle is adjacent. So then, if my theta was here, let's say this is theta prime, my opposite would be where adjacent for the purple angle. And then adjacent would be opposite for the purple angle, but hypotenuse will remain the same. So then we have seen 30, 60, 90 triangle and 45, 45, 90 triangle, right? What you need to remember is the ratio. So and we're gonna tweak these ratios a little bit because when we look at the unit circle, so I filled it out, I'm gonna draw a little line here like this. So then I can draw a right triangle. Then this angle right here is a 30-degree angle. That means that I have 30, 60, 90 triangle, except our hypotenuse is 1. And if you look at the original ratio of this triangle, the hypotenuse for this triangle is 2. So how can we make this triangle similar to that triangle? Well, we divide everything by 2 because the hypotenuse has to be 1. So then my, so this is 30 degrees, right? My adjacent is square root of 3 over 2, and my opposite is 1 over 2. And sine is opposite over hypotenuse, and since hypotenuse is 1, I can just write whatever is in the opposite, which is 1 over 2. So basically, sine of 30 is 1 over 2. And then cosine of 30 is square root of 3 over 2. Always, always, for 30 degree. But what is interesting, I'm going to show you now, is this. Do you remember how I said the adjacent is square root of 3 over 2? And opposite is 1 over 2. This is a coordinate point, meaning that the first part is x coordinate, and then the second part is a y coordinate. Look at how long my x is. It's square root of 3 over 2 long. And then y is 1.5 long, right? So that's how we are going to fill out this triangle, this unit circle, because my hypotenuse is 1, the opposite and adjacent just becomes the distance from the origin. So let's look at the 60-degree one, because that's the special triangle. We're going to still use this triangle right here, except now 60 degrees is my angle. Then adjacent is 1/2. That means that cosine is 1/2. Adjacent is 1/2. So let me draw this triangle right here. this is 60, right? Adjacent is 1/2. And then opposite is square root of 3 over 2. So then my x coordinate for this one is 1/2. And the y is square root of 3 over 2. As you can see, it's a flipped version of 30 degree. And 30 and 60 relationship would be like that. If sine of 30 is same thing as a cosine of 60. And sine of 60 will be same as a cosine of 30. And what's fascinating about this circle is then because 120 degree is something that we cannot draw as a triangle, right? Because if you have a right angle, having 120 as an angle would violate the rules of a triangle. The inner angles has to add up to 180 degrees, and it's already 210 degrees, right? But we can use logic and expand this first quadrant into second quadrant. So let's look at what I mean by that. If you kind of draw a little line here, do you see how that this y value is actually the same as this y value? So that's why the y coordinate for 120 degrees is square root of 3 over 2. And if you draw the triangle right here, it's basically the same triangle as the 30, 60, 90 triangle. It's just flipped, meaning that my x value will be the same in value, but the sign will be negative. So it's a negative 1/2. Does that make sense? So then we can apply the same for this 150 degrees as well. If we draw a little line, you see that how the y's are the same. So this will be also 1/2. But then my x will be a flipped version, so it's a negative square root of 3 over 2. Let's go to the third quadrant. So third quadrant, if I draw a line like this for the 210 degrees, you can see that 150 degrees and 210 degrees has the same x value, right? Same x value, so it's a negative square root of 3 over 2. And the y value will be now negated because it's in the third quadrant. So both x and y values are negative in the third quadrant. Same thing with the 240 degrees, because we're only looking at 30, 60, 90 degrees. It's still negative 1/2 because that's what it was for 120 degrees. And then it switches to negative square root of 3 over 2 for y because it flips. And we can do here. If you look at the x value, it's the same x value. So it's a square root of 3 over 2. And then we can actually look at it like this, right? It has the same y value as the third quadrant. So it's a negative 1/2. Same thing with this one. It will be 1/2 for x. 1/2 for x. And then negative square root of 3 over 2 for y. And so we completed partially of this unit circle. So we completed anything that was divisible by 30 degrees, basically. All right. So if this makes sense and the relationship between, you will know that for unit circle, essentially, if you have the first quadrant memorized, this part memorized, then the other ones are basically using symmetry, and that's it. So you don't have to re-memorize the second and third and fourth quadrant. You can just simply use the logic in the coordinate plane and then do that, because like the numbers won't change. You keep seeing the square root of 3 over 2 and 1 over 2, right? It's because it's a ratio, so it doesn't change. It's just the positions have changed. So if this had made sense to you, let's look at the 45, 45, 90. Again, our problem is that this hypotenuse needs to be 1. And right now, it's a square root of 2. So we are going to divide everything by square root of 2. But when we were learning about the radical, we didn't like the radical symbol to be in the denominator. So then we have to rationalize. So in order to rationalize, we multiply square root of 2 over 2, square root of 2 over square root of 2 to both the numerator and the denominator. So then it becomes square root of 2 over 2. And same thing with this guy. So this tells you that sine and cosine is both square root of 2 over 2. And what we saw here, that the distance from the origin to the x value was your cosine value. And then, cosine value is the x value. And then distance from the origin to the y value was your sine value. So then, but because they're the same, it's just going to be square root of 2 over 2 for both of them. Here, because it's in the second quadrant, the x will be the negative and the y will be positive. And then the third quadrant, they're both negative. And then for the fourth quadrant, the x is positive, but the y is negative. And then we completed the unit circle. I will fill out the 0, 90, 180 because that's what we did yesterday. So here, x is 1, but y is 0. It's the opposite for this one. And then this one is a negative. And then the last one, which is a 270 degree, is 0 and negative 1. So it can be very overwhelming in the beginning because there are just simply a lot of numbers. But once you understand how this unit circle is constructed, it's not very hard. And like I said yesterday, it's the most helpful tool that you can have it memorized for trigonometry. Therefore, I really want you to study the first quadrant, because the first quadrant is basically the base of how you can build the second, third, and fourth quadrant and complete the unit circle. And so, one thing that I kind of indicated but really didn't conclude was this. Let me redraw the 30, 60, 90. And because this was in the unit circle, the hypotenuse is 1, right? So the opposite and adjacent is here. And if you look at this coordinate point, it was the cosine of 30 degree was my x coordinate, right? Because cosine is adjacent over hypotenuse. So x in the unit circle was a cosine of theta. And this height was sine of 30, meaning the y is sine of theta. And this is a very important application for trigonometry and anything that uses trigonometry in an algebra sense. So remember that x is cosine theta and y is a sine theta. And one way that was always helped me to remember that is c comes before s and x comes before y, right? So cosine goes with x coordinate and sine goes with the y coordinate. And theta is again an unknown angle theta, unknown angle value. So it's a variable just like x. And so that's it for today. And today's work will include how to convert radian measurements to degree and vice versa, and also maybe using the unit circle to answer questions like what is sine of 150? Well, sine of 150 is a y value for 150. So you look at the y value, it's 1/2. So the sine of 150 is 1/2. So using unit circle, you're going to answer questions that normally that you wouldn't be able to answer because in your mind, the trigonometry only works with the right triangle and 150 is not one of those angles. But we have expanded your angle world a little bit in algebra sense. So yeah, try those problems and let me know if you have any question about this lesson. And I will see you